Today is day 3 of Taylor series, and what we're going to learn how to do today is to build a Taylor series very quickly using a specific type of function. So, we are going to be dealing with functions that are rational. What's the root word of rational? Ratio. The mathematical root word is ratio, and ratio means what? A fraction. So all of the functions you're going to see are going to look like fractions. Okay? But before we do this, we need to do a little bitty review of geometric series, because this is the foundation of what we're doing today. All right. Geometric series look like this. They are n equals 0 to infinity, a r to the n, where a is the first term, and r is the common ratio. In other words, what you multiply to get from one term to the next. So, suppose I told you to start with a equals 2 and r equals 3. How would you write this series using those numbers? Well, you would write n equals 0 to infinity with a sigma. And then what would you write? What comes next? 2 times 3 to the n. Done. Okay? So if you know what a is and you know what r is, you can quickly write the series. Look at the next one. What if a is 2 but r was negative 3? Sigma again, 0 to infinity. Now, usually when r is negative, you've got to put it in a parentheses, negative 3 to the n like that. Okay? Now, what if a was 1 and r was x? How would that look? X to the n, 1 times x to the n. The 1 is not necessary, but a lot of times we just go ahead and put it there to show you what a is. All right? So, throughout the process of what we're doing today, you're going to be given a problem. You're going to be able to find out what a is, find out what r is, then quickly, you're done. There's the series. There it is. Okay? We can use our knowledge of the series to write this power series, as long as you can take your problem and write it like this. It has to be a over 1 minus r. So if you can take the problem that I give you and make it look just like that, you can make a power series out of it, just like that. Okay? Now, why is that fraction important? That fraction, what we learned, is the sum of the series. Okay? Now, this is review in this box. This is what's basically on your geometric series page in your flip book. Tells you that it converges to the sum of this as long as the absolute value of r is less than 1. Just like we did with ratio test. Absolute value, less than 1. And it diverges if the absolute value of r is greater than or equal to 1. Okay? So, with those little tidbits in the back of your mind, let's take a look at this first problem. Problem says, find a power series for f of x equals 1 over 1 minus x squared, centered at 0. So I've got to write the power series, number 1. Then it wants me to write out the first 4 non-zero terms. We've done that before. And the general term. And then I want to know where the series converges. Now, we did this 2 days ago with Taylor and Maclaurin, and it was pretty involved. We had to figure out the pattern, then we could write the nth term, then we could do the interval, then we could do the r. We did a lot of stuff, but I can take what took us 15 minutes and knock it down to 5. Just really quick to do this problem, okay? So what you do is you take your function and you set it equal to this fraction that I talked about up here. So off to the side, write down a over 1 minus r equals 1 over 1 minus x squared. Now, setting the two equal to each other, we're going to be able to determine what is a and what is r. So, how do you know for sure? The key is right here. These two both have to be 1s. So whatever your problem says, that number right here better be a 1. If it's not, we're going to have to adjust it. But right now it already is, so we're good to go. Since these two match, I can immediately find out what a is and what r is. So based on the equality of those fractions, what number is a? 1. And what is r? X squared. Okay? So I can immediately write the series. N equals 0 to infinity. How do I write the series? Do it just like we did at the top of the page. 1 times x squared to the n. Done. I wrote the series that fast. Okay, what we used to have to do was write out a few terms and then kind of figure out what's going on and then get the sum of the, then get the series. We're going to do it in reverse. We already know what the series is. Now we're going to write out the first 4 non-zero terms. No, non-zero does not mean plugging in 0. It means after you clean it up, is it 0 or not? Now, let me go back for a minute. I didn't mention this earlier. How did we find a series before? Do you remember? It involves some derivatives. Do you remember the other day when we were doing series, we had to take the first derivative, then the second derivative, and the third derivative, and the fourth derivative, and then we plug in the number, plug in the number. We could do that to this problem, but that's a lot of work. But look how quickly I'm done. I've already got the series. I've already got the nth term, and I can just write the series out from this. Okay? So if I plug in 0, I get 1 x squared to the 0 plus 1 x squared to the first plus 1 x squared squared plus 1 x squared to the third. So instead of building my series like I had to do with the taking the derivative over and over again, putting the factorials underneath and all that fun stuff, I can quickly, knowing what a and r are, build the series that way. So I just kind of went in the back door. Very quickly got my answer. No derivatives needed. Not at all. Okay? So let's clean this up. Are all of those non-zero terms? Let's see. What does this first term clean up to be?
1.
That is 1. Plus x squared plus x to the fourth plus dot dot dot, and I forgot that on the top. That's what makes it a series. So, find a power series. Done. Give the first 4 non-zero terms and the general term. Now the general term is what's in here, but just cleaned up. So what would that be? Is it 2n or n plus 2?
2n.
It is 2n. There's my general term. We're looking at what's inside the sigma. The inside of the sigma, we clean it up. So 1 times whatever, the 1 goes away, and the 2 and the n multiply. So it's x to the 2n. That's the general term. All right? For what values of x does your series converge? Okay, this is also much easier than it used to be. Okay, the formula says that it converges as long as the absolute value of r is less than 1. Where's r? Oh, it's right here. So all I have to do is write the absolute value of x squared is less than 1. So put your r in the absolute value, and we solve it like we solved them the other day. How do we take the absolute value bars off again? Do you remember?
You change it to the -1.
You put the -1 in front of it, exactly. Now, this is what we usually do right there. The squared kind of makes it a little weird, though. Can something squared ever be negative? No. Okay. But what I plug in for just plain x, if I square it, it could be negative, right? If I put -1/2 in there and I square it, is it going to be less than 1?
Yes.
If I put -1/2 in here,
Yes.
what's -1/2 times -1/2?
1/4.
1/4. Is that less than 1? Yes. So this math sentence isn't completely accurate. What it should be is just -1 is less than x is less than 1. Because any number between -1 and 1 is going to work. Okay. X squared is already going to be greater than -1.
It's already.
Okay.
Wait, so we take off this square?
Yeah. Let me. I didn't want to go down the more involved road, but let me just talk about it for a minute, okay? When it's squared, x squared is really between 1 and 0 because it can never be negative, right? Does that make sense? Okay. If you take the square root of both sides, however, what is the square root of 1? It's plus or minus 1. That's why it goes back to negative 1 to 1, even though this says 0 to 1.
Okay.
Okay? Does that feel better?
Yeah.
Okay. So, now, after we did that with ratio test, which we don't have to do ratio test, right? We already got the answer. Okay, then we'd have to test the endpoints. We plug in negative 1, see if it works. We plug in positive 1, see if it works. We don't have to do that. Why? Because it tells me that it diverges if the absolute value of r is greater than or equal to 1. So if it's equal to the endpoints, it's not going to work. So we don't have to test the endpoints at all. We can immediately say that the interval of convergence is negative 1 to 1 with parentheses automatically, because geometric series, which is what this is, always diverge at the endpoints.
Wait, so the other times that we had to test the endpoints is because it wasn't geometric?
Correct. We have to test the endpoints if it's not geometric. The geometrics are a special case. They get all the shortcuts, and that's what we're doing today. The shortcut that allows us to build the series immediately, and the shortcut that allows us not have to do the ratio test. We just take the r and put it in the absolute values instead. And the other shortcut means we don't have to test the endpoints. So we got 3 done.
Why does it always diverge at endpoints?
Because up here it says it diverges when the absolute value of r is greater than or equal to. The equal to is on this one. Equal to means the endpoints. So, could it equal 1 and converge? No, because it says here it diverges if it's greater than or equal to 1. It's always going to diverge at the endpoints. Okay?
So this process only works if the fraction is set up like the
That,
set up.
or if you can make it that way.
Okay.
Okay, if you can make your function look like a over 1 minus r, you can do this quick method. Okay? That's what we like.
So the bracket is for diverge?
The bracket is for converge. Negative 1 to 1, everything in between negative 1 and 1 is the converging. But the numbers themselves are not going to converge. That's why we do not put brackets. If we put brackets, that meant that those numbers converge. Okay? All right? Any other questions? All right. At the bottom of the page, it says, on your calculator, graph y1 to be the function that we just messed with, and y2 the first 5 terms of the series. Let's change that to 4, because we wrote it out 4 terms. Okay? So take your calculator, and let's do that. I've got to clear my calculator, because I don't want you to see what I've done. So, here we are. We're going to put the fraction bar in y1, 1 over 1 minus x squared. And then in the second one, we're going to put in 1 plus x squared plus x to the 4th plus x to the 6th. The first 4 terms we wrote out on the series. Okay? Now, do not push graph. Now, do any of you in here have a color graphing calculator? One of you does? Okay. You are at an advantage, because when you graph 2 graphs that are really close together, it's kind of hard to tell where one graph is and where the other one's not. Okay? But we're going to do something on these calculators that are non-color, both 83 and 84, that will help you to see how one graph differs from the other. What I want you to do, please, is on this y2 line, I want you to arrow left as far as you can, to where you're on top of that dotted line over to the left. Okay, everybody do this. The arrow is left as far as you can go. This allows us to change the way the line looks. We can make it thicker. We can make it shade on one side or the other. We're going to make it thicker by pushing enter one time right here. And notice that it's now a big fat line. Now move to the right. You can see it better. Y2 is a fat line now, and Y1's a skinny line. So now when you graph them, you can tell which one is which. Okay? Are you with me? Push zoom 4, please. Zoom 4. So here's Y1, and here comes Y2. Where did Y2 match Y1? On the top part. Up here at the top. That's where Y2 and Y1 are on top of each other. Is that what yours did?
That was the darker one.
It's the lighter one was there first, but the darker one went right on top of it.
That's crazy.
Okay? Where did it say in this problem that this series was centered?
At 0.
At 0. So does it make sense that the top one is matching the curve? Because that's at 0. All right? Trace on each graph to these two numbers. We're not going to trace. We're going to do something that's a little more, obvious. Here's what I want you to do. I want you to push second and table. Now mine is messed up. I need to go back and do table set. Yours should still be in ask mode. Does it still look like, does it have only like 2 or 3 things in there, or is it blank? Or does it have all of 0, 1, 2, 3, 4, 5, 6?
It's blank.
Is everybody's blank or only have a couple things? Okay, try to push delete over and over and see if your numbers go away. If it doesn't, let me help you. Anybody's not going away if you push delete? Okay, I want you to type in 1/2 to that first X box. Look at the 2 Y values. The first one's the function, the second one's the series. How close are they? When you're at 1/2. 1/2's pretty close to 0, so we're getting a pretty good estimate, right? Okay, now it says type in 2. How different are the answers at 2? Extremely. One is -1/3, the other one's 85. So the whole point of this question was to emphasize the fact that the series is only good for estimating the curve near the center. Does that make sense? 2 is not far from 0, but it's too far right now. It's way too far. Okay. So let's write it down. The Y values at 1/2 are very close. But they are very different at 2. The series gives good estimates as long as we stay near the center. The center point. I don't put point because the center could be 5. All right, do y'all have any questions about what we just did? Got to stay near the center point. All right, turn the page. Got to move it down. All right, now we're going to do another problem, but our problem is not set up exactly the way we need it to be, so we need to tweak it just a little bit. Okay, so our function looks kind of like what we want, but not exactly. So let's come over here and write down a over 1 minus r equals 12 over 4 plus x. Okay, so like I said, the first number on the bottom must be a 1, and it's not.
Or we can reduce it back, right?
So what do I have to do to that 4 to make it a 1?
About 1/4.
Take out a 1/4, divide by 4, same kind of thing. So we're going to divide.
Why can't you just divide the top and bottom by 4?
That's what I mean. That's what exactly what I meant. Divide the top and bottom by 4. That's exactly what I'm going to do. But you got to be careful with that x. So watch what's going to happen. So a over 1 minus r equals, what's the top going to be?
3.
3. And then 1 plus what? X over 4. Are you with me on that?
Yes.
Okay, now we know what A and R are. What's A?
3.
That's why I take a breath between the two. R. What is R? Negative X over 4, because the formula says 1 minus R. Okay? Now, this is going to be much more helpful if I move the X off the top of the fraction. And so what would it say instead if I put the X out to the side?
Negative X times 1/4.
Negative 1/4 X. That's what I want. Negative 1/4 X. That's going to be the easier way to use it. Okay? So now we build our series. N equals 0 to infinity. If you have trouble writing sigmas, which I did when I was your age, could not do it, do the best you can. Just write a sideways M. This is 25 years of experience learning how to do it, and I still don't do a good job. So what's my series? 3 times negative 1/4 X to the N. Done. There's my series.
That's crazy.
Okay?
Wait, why is it? Oh, never mind.
Okay, remember the R goes into parentheses to the N, especially if it's negative.
So the 1 just disappears?
Yes, the 1 just disappeared.
Yes,
Because
because it only goes 1.
A is the top and R is what comes after the 1. Okay? So now, time to write out the series. So it's 3 negative 1/4 X to the 0. Now, if you know what that cleans up to be, you don't have to write all that excess stuff down. I like to write it because it shows you the pattern. To the first, plus 3 negative 1/4 X squared, 3 negative 1/4 X to the third. Please notice that the powers are outside the parentheses, not inside. It's not just for the X, it's for the negative 1/4 also.
I got plus dot dot dot.
Plus dot dot dot. Oh, thank you. All right, equals. So, what does the first term clean up to be? It's 1. Anything to the 0 power is 1, so that's going to be 3. Plus, what is 3 times negative 1/4? Negative 3/4 X to the first. Plus, now I have to square the negative 1/4 first and then multiply by 3. What's negative 1/4 times negative 1/4? Positive 1/16 times the 3. So it's going to be positive 3/16 X squared. And the last term is going to be, what sign?
Negative.
Negative. I know the top number is going to be 3 because there are always 3's, right? Now I need 4 to the third. 64 X to the, oops, I almost wrote a 4. X to the third. Plus dot dot dot. Now, as far as trying to rewrite the general term, there's really not a whole lot of cleanup that you can do with this. There's no power to multiply to the inside, so let's just write it as 3 negative 1/4 X to the N. That's the general term. You can always just recopy what you wrote in the series. Okay? So far so good. So we've written the series with the sigma. We've written out the first 4 terms. Now we got to do the convergence interval. Okay, so we now take R, which is negative 1/4 X. We throw it in an absolute value, and we say it has to be what? Less than 1. And now we do what we were told before to take those bars off. But wait a minute. What is the absolute value of negative 1/4 X? Positive 1/4 X. Like so. All right. Now remember how to work this. Cover up one side of the inequality. Look at what's left. How do you get the x by itself?
Divide by 4.
Not divide by 4. Multiply by 4. Multiply by 4. So what's my left-hand number going to be? Negative 4 is less than, x is less than 4. So the interval of convergence and I don't need to write that sentence every time. I just wrote it that first time to let you know you don't have to test the endpoints. Negative 4 to 4, we're done. We don't have to test the endpoints on this whole worksheet. So how are you doing? This is all we're doing today, basically.
We're good.
Are you good? Okay. The last problem has a little bit of a twist. So I'm going to get it started for you, and then you're going to finish it and do the whole thing yourself. Are you ready? Okay, look what's different. It's centered at 3. Okay? So, how does a power series look if it's centered at 3?
X minus 3.
Instead of x, 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 it has x minus 3, x minus 3, x minus 3. So, that tells me... Now, let's just go ahead and write this down before I finish my sentence there. Okay. There is a problem in the homework where the x comes first on the bottom. You got to switch it. X has to come last. Okay. Now, I have to make the bottom something minus x minus 3. Which means I'm going to take this 4. I'm going to blow this up. I'm going to take this 4 and I'm going to split it up. I have to have an x minus 3 here because it's centered at 3. Okay? Now, what I'm about to write is scratch work, so I'm going to write it in a different color. If I distribute this x, that would be minus x plus 3, right? Mm-hmm. How much of my 4 is left? 1. If I put a 1 right there, is this going to equal 4 minus x?
Yes. Yes.
No.
I don't know why you put x minus 3.
It says in the problem it's centered at 3, so it has to have an x minus 3.
Wait.
Like, so when it's centered at 0, you don't...
You don't have to worry about it because it's x minus 0.
So 1 minus r on the other side.
Okay, let me show you the way that I did this. If this is kind of confusing you, so 4 minus, don't write this down just yet, equals something minus x minus 3, okay? So I'm taking the 4 minus x that I've got, and I need to turn it into something minus x minus 3, okay? So 4 minus x equals something minus x plus 3. Are you with me? Okay, I want to solve for the box. First thing I want to do, get rid of my x's. If I add x to both sides, x's are gone. Agreed? So 4 equals the box plus 3. So what's the box? 1.
Oh.
Okay, so if you like that, go off to the side and write that down, and I'll give you a second to do that. If you can just see it and know that it's a 1, write it as a 1. So I took my original denominator, wrote it down with a box minus what I need. I need x minus 3. If I needed centered at 5, I would have written box minus x minus 5. And then I worked it out. Get rid of the x's first, and then you can figure out what goes in the box. So this doesn't happen very often. It's only when the center is not 0. Okay. Now that I've written it this way, am I ready to go? Can I write down what A and R are going to be? What is A? 5. What is R? Aha. So,
X minus 3, not negative x minus 3.
correct, because the formula says 1 minus R. So 1 minus the parentheses. Okay, so now you finish it. I want you to now can I can erase this. Write the series. Write the series. Write out the first 4 terms, clean it up. Find the interval of convergence. You can do it. So most of you should be finished with this by now, but I do want to talk about the radius of convergence. On the previous problem, when we had the negative in the absolute value, we took it out and made it positive. But there may be some of you in here that think that you can do the same thing with this one, and you can't. This is not x plus 3 is less than 1. You cannot change this minus 3 to a plus 3. You have to leave it as a minus. So first I want to go ahead and finish the problem, and then I'm going to tell you why. Okay? So you put the negative 1 in the front. What do you do to all three terms to get the x by itself? Add 3.
Oh, yeah.
So those cross out, and you get 2 is less than x is less than 4. So our interval of convergence is 2 to 4 with parentheses. Okay. Now, why can't you do that? So we had negative. So let's take an example this way. If you have negative 2 times 3 in an absolute value, can you make that 2 positive and bring it out? Well, let's see. What is negative 2 times 3? Negative 6. Does the absolute value of negative 6 equal positive 6? Yes. So if they are multiplied, you can do that. But if you have something like 5 minus 3 in an absolute value, can you make the 3 positive when you bring it out? No, because this is 2 and this is 8. They're two different numbers. So this minus does not change to a plus. Can't do that. But you can do it, that's supposed to be a check mark, when it's multiplied. Yes, sir?
What do you make everything negative? Not everything, like, so what do you change both of the signs?
If you did that, so let's say you had 5 minus 3 and you changed both of the signs like that. Let's see what happens. This is 2, this is negative 2. So that doesn't work either. It's a good try, but it doesn't work, unfortunately. Any other questions about this problem? All right.